Hi, this is Mrs. Doris, and this is lesson 8-6, factoring ax squared plus bx plus c. Our objective is that you will factor trinomials that have that form, and in this case, a is going to be a number greater than or different from 1. All right, so here are the steps that we're going to take to factor ax squared plus bx plus c. And if you will follow these steps for each problem, you'll find that it's very easy. And after you do several of them, then you'll have the steps in your head and find it simple. Step 1 that we're going to do is we want to find the factors of a times c. In our example, a is 4 and c is 2. 4 times 2 is 8. All right, so step 1 is to multiply those two numbers together, a and c. So 4 times 2 is 8. Now we want the factors of 8 that add up to the middle number, which would be 9. And the factors of 8 that add up to 9 would be 8 and 1. All right. Step 2, replace the bx term with two x terms, each having one of the factors found in number 1 as their coefficients. So we're simply going to take our 8 and our 1, and what we're doing here is we are renaming the 9x as 8x plus 1x. Now, in step 3, what we're going to do is we're going to group the terms. Group the first two terms together, the 4x squared plus 8x, and group the last two terms together, the 1x plus 2. Now we're going to factor out the greatest common factor of each pair. So looking first at this, our greatest common factor of 4x squared and 8x, looking at the 4 and 8, would be a 4. And then there is an x in each term that we can factor out. So once we factor out the greatest common factor, we want to write what's left. Well, if I take 4x out of this, I have an x left. 4x times x is 4x squared. And if I take 4x out of the 8x, I have a 2 left. So I have 4x times the quantity x plus 2. Now in the second one, 1x plus 2, we don't have a common factor. So when we don't, the only common factor they have is 1. So we have x plus 2 left. Now, the last thing that we do then is use the distributive property to rewrite as the product of two binomials. And basically what we're doing is we are factoring out the greatest common factor in each pair. Well, notice we have x plus 2 as a factor and x plus 2 as a factor. So we're going to factor out that x plus 2. Everything else that you see, once we factored that out, the 4x and the plus 1 become our other factor. So let's FOIL and check it to make sure that we get the original trinomial. All right, so we have x times 4x is 4x squared. Outer terms, x times 1 is 1x. Inner terms, 2 times 4x is 8x. And multiplying our last terms together, 2 times 1 is 2. Combining the two like terms, we have 4x squared plus 9x plus 2, which is the same as the original trinomial that we started with. So that's a way of checking it once you have your two factors. All right, so let's do it again. And this time we'll talk through the steps as we do them. What is the factored form of 6x squared plus 13x plus 5? All right, the first thing that we want to do is identify our A and our C. A is 6, C is 5, and so we want to take A times C, which would be 6 times 5, which is 30. Next, we want to find the factors of 30 that will add up and give us the 13 in the middle. So let's start in and make a list. We've got 2 times 15. We could include 1 times 30. 3 times 10, and you know what? Right there we can stop, because what I notice is these two factors multiply together to give 30, 3 times 10, and 3 plus 10 is equal to the 13 that we're looking for in the middle. So I'm going to rewrite my trinomial. I have 6x squared. Rather than the 13x, I'm going to replace the 13x with 3x plus 10x. And that's using each of these factors as a coefficient of the x term. And then plus 5. All right, next I want to group. I'm going to group the first two terms together, and I'm going to group the last two terms together. Now I want to identify any common factor in each group. So looking first at the 6x squared plus 3x, 6 and 3 have a greatest common factor of 3, and of the x squared and the x, we can pull out an x. So writing what we have left, 3x times 2x would give us the 6x squared, and 3x times 1 would give us the 3x. Pulling a greatest common factor out of the second pair of terms, 10 and 5 have a common factor of 5, and there is not a variable common to each term. So 5 times 2x would give 10x, and 5 times 1 would give 5. Now, notice, what I have here in red is the same term. So let's pull out that greatest common factor, and that will be one of our factors, 2x plus 1. And then what you see remaining in the blue is going to be our other factor, 3x plus 5. And I won't take time to use FOIL to check it to make sure we get the original trinomial right here, but you can use FOIL always to check your answers to make sure that it does generate the polynomial. All right. Let's look at the general form of ax squared minus bx plus c. In ax squared plus bx plus c, suppose the ac is positive and the b is negative. What do you know about the factors of ac? All right. Well, if a times c is positive, but they have to add up to give us a b that is negative, both factors would need to be negative. And the reason we know this is a negative times a negative is equal to a positive number. All right? And a negative plus a negative number is always going to be equal to a negative number. So for this reason, we know that both of them would have to be negative. All right, so let's take an example. In this case, our example, we have 4n squared minus 8n plus 3. So again, let's identify our a and our c, 4 and 3, and multiply 4 times 3 together to get 12. Now we want factors of 12 that are going to add up and give us a negative 8. So in order for them to multiply together and get a positive 12 and add together to get negative, we know they both have to be negative. So factors of 12, it could be negative 1 times negative 12, or negative 2 times negative 6. And we can stop right there, because we know that negative 2 times negative 6 is positive 12, and negative 2 plus negative 6 is equal to negative 8. And that's exactly what we want in the middle. All right, so let's replace in our 4n squared. Rather than minus 8n, we're going to use these two numbers right here as our coefficients. So we have minus 2n and minus 6n, which together give us this negative 8n that we want, and then plus our 3. Now, I highly recommend at this point that before you even group them, or let's go ahead and group, but be very careful here that you want to make sure that you are adding the opposite. And the reason this is so important is look what happens when we group. All right, and it's just going to be very, very, very important that we have a plus sign right here in the middle. So if you have a minus sign there, you want to make sure that you add the opposite before you start factoring out the greatest common factor. Okay, our greatest common factor in our first pair is going to be 2n. And what would be left if we take 2n out of 4n squared is another 2n. And 2n times 1 will generate the minus 2n. All right, plus. Now let's factor out the greatest common factor of negative 6n and 3. And because 6n is negative, we're going to factor out a negative number. And 3 is common to both the 6 and the 3, so we're going to take out a negative 3, and then let's see what we have remaining. Well, negative 3 times 2n would give negative 6n, and negative 3 times a negative 1 would give this positive 3 right here. So now, again, let's look and see what we have. We have a common factor in each grouping of 2n minus 1. So 2n minus 1 will be one of our factors. And then what's left, the 2n and the plus negative 3 is going to be our other factor. 2n plus negative 3 is the same as 2n minus 3. And once again, you can use FOIL to check your work and make sure that you, if you FOILed it, you would come back and get your original problem. All right, sorry for the interruption. So our two factors would be the quantity 2n minus 1 and the quantity 2n minus 3, which you could check by using FOIL to make sure that you get the original trinomial. All right, let's do another one. What is the factored form of 10x squared plus 31x minus 14? All right, identifying our A and our C, A is 10 and C is negative 14. So 10 times negative 14 gives us a negative 140. All right, so right off we know that we're looking for two numbers that multiply together that give us a negative number. And in order for two numbers to multiply and get a negative number, one has to be positive and one has to be negative. So let's begin, first of all, by just looking at the factors of 140. We know that Well, we'll start with 1 and 140. We have 1 times 140, 2 times 70. We know that because 140 ends in 40, which is divisible by 4, that 4 will go into it. And 4 times 35 will give us 140. 5 will go into it 28 times. 10 will go into it, of course, 14 times. But we've already found the one that's going to work. We want to get a positive 31 in the middle. So what we see here, if we look at the 4 and the 35, if we make the 4 negative, then we know that negative 4 plus 35 is equal to 31. And that's what we want in the middle. All right, so let's rewrite the whole problem. And we're going to replace the 31x with our two factors here. So we have 10x squared. Rather than the 31x, we're going to rename it as minus 4x and plus 35x, and then minus the 14. All right, now let's group them. We'll group the first two together, and we're going to group the last two together. Now, it's really nice when you have two factors, one negative and one positive. If you'll put the negative one first, then it will fall within the bracket and you won't have to worry about changing your sign right here. Okay, so let's factor out the greatest common factor of 10x squared and minus 4x. Well, 10 and 4 have a greatest common factor of 2. And x squared and x have a greatest common factor of x. So we have 2x, and what remains? 2x times 5x would give 10x squared, and 2x times a minus 2 would give the negative 4x. All right? Now let's go ahead and we're going to look at the second pair of numbers. 35 and 14 have a common factor of 7. All right, and x is not contained in the 14, so we don't have a variable we can bring out with us. So 7 times 5x would give the 35x, and 7 times a minus 2 would give the minus 14. Now notice we have the same factor here in the blue. So one of our factors of the trinomial is going to be 5x minus 2. And our second factor is going to be what we have in red, 2x plus 7. All right, and that's taking this 2x and plus 7. And once again, here's our answer, and you could use FOIL to check it and make sure that you get the original polynomial. Now, I want to show you another method which you can use if you wish, but you don't have to. The first method works perfectly fine, and it is taught in your book. This method is not. All right, the Lizzie method, this was actually, and you can Google it, this was figured out by a high school student, and it works. And if anyone can prove to me why it works, I would be happy to listen to you, and I can possibly provide you some extra credit for that. Find the factors of AC that add up to B. Okay, so this is the same step. A is 5, C is negative 4. 5 times negative 4 is negative 20. So you want factors of negative 20 that add up to a positive 19. And that's pretty easy. I think you can see that 20 times a negative 1 would give you negative 20, but 20 plus negative 1 would give you the 19 that we want in the middle. All right, so we have factors of 20 and negative 1. What you do then is step 2. Divide each factor by a. All right, well, a was the 5. So we're going to divide 20 by 5, and we're going to divide -1 by 5. And then you want to reduce any of the fractions. Well, -1 over 5 cannot be reduced, but 20 over 5 could be reduced to 4 over 1. And even though we know that this is the same as 4, leave it in fraction form. Now here's the cool part. Step 3, the denominators are the coefficients of the variable, making the first term of each binomial. So let's do that part. I'm going to draw my parentheses. And notice my denominators are a 1 and a 5. So since we're using z as our variable, our first term is going to be 1z, which of course I would not have to show the 1, and 5z. Our numerators, and I'm sorry, I circled the wrong 5. I don't want to confuse you here. We'll use this one right here. And I'm sorry, let me circle that in red. All right, sorry for the interruption. Okay, let's go back, just to be sure that there's no problem. It might help if we put our fractions in boxes. The 20 over 5 right here reduces to 4 over 1, so we're done with this at this point. All right, so circled in red, our denominators become the coefficients of our z term, and then our numerators are what go with it. So plus 4 and 5z minus 1. All right, let's do another one. Problem 3, applying trinomial factoring. The area of a rectangle is 8x squared plus 22x plus 15. What are the possible dimensions of the rectangle? Okay, what we're going to use is we'll use the Lizzie method to demonstrate this again. Now we know that area is length times width. So we're looking for two factors multiplied together that will give us the 8x squared plus 22x plus 15. All right, so following the steps of Lizzie, we still take our a times our c. And 15 times 8 is 120. And we want factors of 120 that add up to 22. So let's see. We have 1 times 120, 2 times 20, and right there we can quit because we know that 2 times 20, nope, excuse me. What am I thinking? Let's go back. Ugh. I'm not thinking. It's after school, the bell just rings, so there's my problem. All right, so we have 2 times 60. That won't add up to 22. How about 3 times 40? And 3 and 40 won't work to give us 22. Let's go 4 times 30. And 4 and 30 won't make 22. Let's go 5. And 5 times 24 will give us 120, and that's not going to work either to give us 22. Next factor that will go in is 6. 6 times 20. But 6 plus 20 is 26, not 22. 8 will go in. 8 goes into 120, 15 times. And 8 and 15, make sure we're right here, is not going to give us 22. 9 will not go in, but 10 will. 10 times 12. And wouldn't you know, it's the very last factor in our list that's going to work. So we want to take our 10 and our 12. And that one works because 10 plus 12 gives us 22, and 10 times 12 gives us the 120. So using the Lizzie method, we're going to take our 10 and our 12. And we want to divide them both by A. Well, A is 8, so we're going to divide both by 8. And now we have to reduce. All right, so reducing 10 over 8, 2 goes into 10 5 times and into 8 4 times. So using this factor right here, we have our first factor. Using the denominator as the coefficient of x, we would have 4x plus 5. Reducing 12 over 8, 4 will go into 12 3 times and 4 goes into 8 2 times. So our second factor, using 2 as the coefficient of our x, would be 2x plus 3. Notice the 2 becomes the coefficient of the x, and the numerator, the 3, is what is added on. The same is true with our 4. In the denominator becomes the coefficient of x, and the 5 is what is added on. All right, so our two factors, 4x plus 5 and 2x plus 3. So one of these would be our length and the other our width. And again, you can use FOIL to check it to make sure that we get the original polynomial. All right, problem 4. Factoring out a monomial first. This is reaching the pinnacle of what we're going to do in this chapter. Sometimes when you have a polynomial, you have a greatest common factor in each of these terms. You should factor that out before you do anything else. So when we look at 8, 36, and 20, we notice that 4 would be a greatest common factor of all three terms. So factoring 4 out of 8x squared leaves us with 2x squared. And factoring 4 out of 36x leaves us with 9x. And factoring a 4 out of the minus 20 would leave us with minus 5. Now, I always recommend at this point that you double check before you go further. 4 times 2x squared is 8x squared. 4 times minus 9x is minus 36x. And 4 times minus 5 is minus 20. So far, so good. All right, now, we know that the factored form is going to have this 4 in it. So I'm going to write this 4 down here. And I'm going to go ahead and put in my parentheses, and this will be where I'll put my answer. In fact, we'll just box it in right now. There's our answer. Okay, so I'm left with factoring the polynomial 2x squared minus 9x minus 5. All right, so let's take our a times c. 2 times negative 5 would be negative 10. And we want factors of negative 10 that will add up to a negative 9. All right, well, looks to me like negative 10 times 1 would work. All right, negative 10 times 1 is equal to negative 10, and negative 10 plus 1 would equal negative 9, which gives us the coefficient of the middle term. So let's take our factors, negative 10 and 1, and I'm going to use Lizzie again. We're going to divide by a, and a is right here, the 2. Divide by 2. All right, so 1/2 is already reduced, so I can go ahead and make 2 the coefficient of the x term, and the numerator is added on. And on our second term, negative 10 over 2, we can reduce that one. 2 goes into negative 10, negative 5 times, and 2 goes into 2 once. So using this fraction, our denominator 1 is the coefficient of the x, and I don't have to show it, and then minus 5 is what is tacked on. And again, you can use FOIL here to double check your answer to make sure that you get the original problem. All right, here's some others that you could check if you want. At this point, I would like for you to work on the practice worksheet 8-6. If you have any questions, please ask. And you may use either the Lizzie form or you can use the grouping form that we started out with.